Today, let's take a look at steam service, a very common application for process valves, yet not without its challenges. Steam is used across nearly every industry, from power generation, chemical processing, pulp and paper, to heating systems and more. Put simply, steam is just water in its gaseous state. But it's invisible until it condenses in cooler air, and it also exists in different forms. There are roughly 6 practical variations of steam depending on relative pressure and temperature conditions. However, we're going to look at the 3 primary forms: saturated, superheated, and supercritical. First, saturated steam contains both vapor and liquid water. It's produced when water boils at a given pressure and temperature, and it's commonly used in heating or sterilization processes. Superheated steam is formed when saturated steam is heated even further, existing only as vapor and common in power plants and turbines, particularly where dry conditions prevent blade erosion. Supercritical steam occurs at extremely high temperatures and pressures, beyond the point where water behaves distinctly as a liquid or gas, typically above 1049 degrees F and 3200 psig. But although simple, a fairly common mistake for valve selection is mismatching a particular steam application's actual operating conditions with the valve's material limits, such as using a soft-seated valve with standard PTFE or RTFE seats, which start to deform around 400 degrees F, while saturated steam at just 250 psi can already reach that temperature. The key takeaway is that steam is an incredibly versatile medium. But with that versatility, it presents a lot to consider due to its wide bandwidth of pressure fluctuations, temperature ranges, and erosive condensate. To learn more about valve and actuator packages rated for your steam application, contact us by phone or email. Thanks for watching.